So the next presenter actually just went to the microphone, so I asked him to come back now. Where are you hiding? Oh, okay. It's getting a microphone. So it's a topic that's also close to my heart. It's about IPv6 and how we can make use of it to do more peering these days. So please, Aleksi.
Thank you. So I am again Aleksi Suhonen from Finland, from Trex, and so the question is: are IPv6 only IXPs coming? We all know that we've run out of IPv4 addresses, which of course has several different definitions. The first definition was that the top level IANA ran out of IPv4 addresses in 2012, and a few months later, the first regional internet registry also ran out of IP addresses. And basically now, if you want IPv4 addresses and you don't have them, you have to go on the open market. There are some exceptions, but you can't get a lot of IP addresses that way. Some years ago, there was a new RFC called, number 5549. It's got a long name, which doesn't really describe very well what it can be used for. This was 2018, but what it basically does is it specifies a way to announce IPv4 routes using IPv6 next hops using BGP. And initially what it was used for was for big operators who want to only run one IP address family in their backbone to tunnel their IPv4 internets and private nets, VPNs, over the IPv6 only backbone. But it can also be used for other purposes, and RFC 8950 just fixes a few things in the old 5549. So it's not much different, but it's a bigger number, so it must be better, right? But basically what this RFC allows network operators to do is free up IPv4 address space for other uses, so that they don't have to go on the market and buy the address space. I've seen some interesting presentations from Facebook or Meta, for example, in recent years, where they've been upgrading first their whole backend and then now their whole backbone into IPv6 only, and then they can start using that address space on their front end. And of course, next they will start work on the front end and the interconnections into other networks. But basically what it boils down to is in normal IPv4 BGP, when routers talk to each other, they first have, on the Ethernet, they have to first make an ARP query to find out the MAC address of the neighboring router. But if you don't have IPv4 on the link, there's nothing you can ARP. So basically, this replaces the ARP query with an IPv6 neighbor solicitation packet, neighbor discovery. So it's a simple concept, but often the implementations have the IPv4 silo and the IPv6 silo pretty separate, so it might be difficult to actually implement in some cases. But there are already a lot of implementations out there, so clearly it can be done. The routers still need an IPv4 address for various sources, uses. I think the most important use is for sending ICMP errors, because your PathMTU discovery, your trace route, several things rely on ICMP. And if you don't have any source IPv4 address on the router that you can use to send that, then it becomes problematic. Usually the router IDs still are also IPv4 addresses, or at least look like IPv4 addresses. So you typically have one loopback address still on the routers, but it's a /32, so it's not so much waste of space. But my presentation today is about IXPs. So why? We already have tons of IXPs and they already have tons of address space. and RIPE even has a special policy for assigning addresses still for IXPs. 2 years ago, or up until 2 years ago, the default size for IXPs IPv4 networks was a /24, so 256 addresses, which is easy to work with for IXPs. So why am I rocking the boat? What's going on? Well, one big reason is that renumbering an IXP is painful. So links in London renumbered from a /22 to /21 a little over 2 years ago. Are there any people here who are connected to links and remember this? Couple very strong hands over there, and a couple of other hands. Yes, so it's always painful. Also, the bigger the subnet becomes that you are renumbering, the pain is multiplied, exponentially. Links has also done this about a decade ago, or the first time they did it was in 1997. So they started as a /24, and then they've renumbered 3 times into what now is a /21. I suppose they have experience in it, but I don't think they still want to do it ever again if they can help it in any way. But of course, the bigger the network, the longer it'll take for them to need to do it again. DESIX in Frankfurt has renumbered only once. What they did was clever in that they had done a /24, and then when they renumbered, they chose a new network where they reserved some space next to it. And then after that, they haven't actually renumbered, they've just made the net mask bigger twice. They are effectively renumbering where you don't actually change the numbers, just the net mask. So it's less painful, but it's still not painless. And thanks for Arnold Nipper and Daniel Wagner for giving the dates and details. NIX in Prague has also renumbered once. They skipped 23. They went straight to a /22 in 2011. Thanks to Marian for this date. I couldn't find any information about NetNode ever having renumbered, so I don't think it actually has renumbered. But NetNode is growing, so that day might come. And so on. There are lots of examples that we could use. So the alternative here is that we have the opportunity to never have to renumber again. So when you are nearing the point where you might have to renumber, you might want to weigh the options if you want to really go through the pain of renumbering, or if you want to switch to IPv6 next hops rather than IPv4 next hops. So there's no real shortage to IPv6 next hops at an IXP. So, and these days, most operators already connected to IXPs have an IPv6 address on the subnet, so they don't need to configure new addresses. They just need to reconfigure how they announce their IPv4 address space. So the previously mentioned NIX from Prague is testing it on their Phoenix subnet. So basically, they've got the public NIX where all operators are welcome, and then this Phoenix subnet is a separate sub-IXP where only security vetted ISPs connect. It would be a good and different presentation why they've done that and how it works and so on. But they are using that to test this out. A couple of weeks ago, they had 6 members, 12 sessions, 128 IPv4 prefixes announced in that subnet using this mechanism. Trex, our exchange point in Tampere, is also testing it. We actually haven't told our members that we're testing it, so we don't have any sessions yet there. But we have a new exchange point in Turku, the 3rd biggest city in Finland, where we are testing only having IPv6 addresses. So basically, a couple of years ago, the RIPE address policy for new IXPs was changed so that you no longer get a /24 by default. You only get a /26, so a quarter of a C class. Which means that if you are growing slowly, you might have to go through 2 renumbering events before you even get to the full /24. So what if we skip IPv4 completely? So you can still exchange IPv4 traffic, but you don't have an IPv4 address on the IXP peering LAN. The thing is, so when we were setting up this Trex Turku, we already had IPv4 addresses in mind that we'd use there. But then we realized that if we start using them, it might be difficult to ever, get them out of there. So if we are IPv6 only from day one, then that will raise the hurdle because we already have some members or operators that would like to connect there, but who either know that their devices don't support it yet or don't know if their devices support it yet. So that's the interesting bit. And but I think it's coming along nicely now that there are actual IXPs around the world testing this. So the European Association for IXPs already a couple of years ago started a working group thanks to Arnold Nibel's email on a RIPE mailing list a few years before that to work on this, to adopt best practices for adopting RFC 8950 at IXPs, and also to test map out challenges, test interoperability, stuff like that. I am one of the chairmen. Andre Gruneberg from B6 is the other chairman. There are members from many big IXPs and small IXPs. There's also members from software developers. So, for example, Nix is the maker of Bird Routing Daemon. NetDev is the maker of FRR, which was also mentioned in the previous presentation. And we've got a GitHub link there where we are collecting information on how this stuff is configured on different routers, basically what ISPs would need to do to get their router to do this over an exchange point. And we are also trying to collect experiences of, bugs or interoperability issues and stuff like that. We are accepting pull requests. So if you like to contribute, sure. We've got a mailing list and a Mattermost channel also for this working group where we accept external members. So talk to me if you are interested in joining those. And also DKIX is looking for a master's or a bachelor's thesis writer on a topic related to this working group. So if you are a student, here's also one interesting opportunity. This was basically just, an additional slide about some of the topics that I could go more into detail if there's interest. But I guess I could end it here and ask if there are questions specific to this thing. And I see there is.
Job Snyders, just speaking for myself. I want to play devil's advocate a little bit, because the list of challenges is quite long, to the point that I'd be like, oh, this does not sound great at all. And if we look at IPv4 availability, in the RIPE region, just like that, you can get a /26. The average IXP, according to PeeringDB, has 26 members. And you can fit 64 in a /26. So I think most IXPs that start never ever in their lifetime would reach, would deplete the initial assignment that they get. But even if they do, they can still double to the point that, and get to a /24. Now, if you're at the point where you have like 250 members connected to your IX, you're a really big IX, and charging your members a one-off fee of 100 euros to purchase more IPv4 space seems super feasible. So this sounds like a shit ton of work, even though IPv4 is still available and is affordable if you really need it. So what's the business case?
Well, this sounds like a shit ton of work, but the reason we have a working group now is to go through these all the issues. We were actually, when we started, we were surprised at how well things already work. So when there are issues, they don't affect necessarily all platforms, just a few platforms, and we are also in communication with vendors to get them fixed. So if 2-3 years from now somebody wants to really start doing this, then hopefully all the issues will be fixed, or at least they will be better understood. As for starting a new IXP, when you start it, you don't know if you're gonna grow or not. So as you say, most don't, but if you do, do you want to? Because this might be a lot of work, but renumbering a 24 into a 23 or 22 is also a lot of work, mostly because a lot of the ISPs don't really have a lot of peering people working for them. Most of those 256 routers don't have a person behind them that will change the address within a year.
I mean, if you start an IXP, the statistics suggest that you're not going to grow beyond a /26, so it's not a problem. If you do, by accident, grow beyond a /26, gee, you're a victim of your success. And again, there is no problem. And renumbering IXPs, is it really that much work? Like, it's a few emails. The people that don't renumber, they don't renumber, whatever.
This is essentially just another way to renumber, except that you've already got the numbers because you are just starting to use your existing IPv6 addresses for IPv4 space as well. So I'd argue that this is less work because all you need to do is add an address family with certain configuration settings into your existing BGP IPv6 sessions.
Okay, final question.
Sure.
Your first slide started with, are we going to see IPv4-only IXPs? And I didn't hear a clear answer. What is, how many years?
Well, as I say, our Turku exchange point is such an exchange point.
So globally, you're the first?
I don't know, but I might be. But then again, Asia is a vast area where there's a much bigger shortage of IPv4 addresses, so there might already be things like that over there that we just don't know about.
Well, yeah, people. Thank you for the presentation.
Thank you for the questions.
So, another token of appreciation. Thank you very much.